Hello friends, I am Dr. Sudhan Sharma from School of Computers and Information Sciences, Indira Gandhi National Open University. And today's session is about calculus, and it is an introductory session about the block number 3 of our course BCS 012 Basic Mathematics. In our earlier blocks, that is algebra 1 and algebra 2, we had explicitly discussed about the various components of algebra. We had discussed about determinants, matrices. We had also discussed about sequence and series, complex numbers, quadratic equations, inequalities, and we had solved ample number of numericals. Now, the next important component in basic mathematics, which is very much required to understand the advanced concepts in the computer science, is calculus. In this session, we are going to give you the brief introduction about what are the topics to be covered in the upcoming sessions related to block number 3, that is calculus, wherein we are going to discuss about the integral calculus and the differential calculus. Apart from this, we are also going to discuss about the application of differential calculus and integral calculus. Now, calculus is actually a very important part. At present, it is contributing from the point of the computer science. It is very much required when we are going to understand the concept of modeling, simulation, optimization, may it be say data science or for machine learning, artificial intelligence, and computer graphics also, wherein we need to explore the concepts of the integral and differential calculus to have the understanding of the concepts. Likewise, Bezier curves, when we are going to establish the continuity among the curves, it is required to understand that we need to have, say, C0, C1, C2 continuity or G0 and G1 continuity. Then the concepts of calculus, that is differential calculus, is very much required. So, actually they form the backbone of many computational techniques in computer science, may it be optimization techniques or the learning, machine learning, and the design analysis of the algorithms. So, the actually integral calculus and differential calculus plays the role of the mathematical tools for solving the complex problems and enhance the technological understanding part of the computer science. So, block 3 is covering 4 units, is comprised of 4 units. The unit number 1 is actually the differential calculus, wherein we are going to understand and explore the concept of the limits and continuity. Apart from this, we are also going to understand the differentiation of sum, difference, product, and quotient of the two functions. We are also going to explore the concept of the chain rules and how to perform the differentiation of the parametric functions, and second order derivatives is an important concept which you need to understand when we are going to explore this unit number 1, which is differential calculus. Now, unit number 2 relates to the simple applications of differential calculus, wherein we are supposed to explore the problems related to rate of change and monotonically increasing and decreasing function, how to find the maxima and minima. So, these are very important concepts when we are going to understand the concept related to machine learning and optimization techniques. Now, unit number 3 is related to the concept of the integration, which is nothing but you can say it is an antiderivative, it is an opposite of the differentiation. And there are different techniques to perform the integration. We are going to explore integration by substitution and integration by parts. Finally, the unit number 4 is about the application of integration, wherein we are going to solve the numericals to find the area under the curve, and this is a very important concept, and you will enjoy the content delivered for the coverage of the topics in the respective units. So, unit number 1, the 4 important aspects are limits and continuity, derivatives of the functions, chain rule, and differentiation of the parametric forms of the functions. So, we will be discussing about these 4 points and in the unit number 1 of the differential calculus. And so far as the introduction to the differential calculus part is concerned, actually you can say that it is a branch of mathematics which focuses specifically on the study for the rate of change and the slopes of the curves. So, it is in fact one of the foundational topics in the calculus, and it has got numerous applications not only in computer science, may it be say economics or physics or engineering or biology and many other areas which are allied to computer science. And in fact, you are supposed to find the derivatives, that how the function changes at the input changes. So, at what rate the things are changing as the inputs are changing. So, you will understand when we will explicitly solve the numerical problems, that what differential calculus is all about. Now, there are ample number of applications of the differential calculus, as we had already discussed, that to optimize a problem, it is generally required that how to maximize the function or how to minimize a function. Say we want to maximize the profit or minimize the losses, then how to perform that. So, by solving the numerical problem. So, optimization problems are very much in the need of the understanding of the differential calculus. Apart from this, determining the slope, which is very much required when we are going to understand the concept of say civil engineering, or when we want to find the maxima or the minima, and we want to perform say motion analysis, then we need to find the velocity, acceleration and other concepts which are explicitly using the concept of the differential calculus. Apart from this, I had already discussed that in computer graphics, when we are joining the Bezier curves, then we need to establish the continuities. Likewise, there are two type of continuities, that geometric continuities, say C0, C1 continuity, parametric continuities are there and geometric continuities are there. In order to establish the continuities, you are supposed to match the slopes, and so that the continuity is, the smoothness is maintained in between the curves. So, that means when we are performing curve sketching through computer aided designing CAD, you are supposed to explore the concept of the differential calculus. Now, so far as the unit 2, that is simple applications of differential calculus, we are going to explore the problems which are heavily related to the rate of change of one quantity. Apart from this, how the variation in the rate of change of one quantity affects the rate of change of other quantity. So, we are going to explore such type of problems explicitly by solving the numericals under unit number 2. Apart from this, in unit number 3, which is related to the integration, we are supposed to perform understand what integration is, what are the basic rules of integration, and how to perform integration by substitution, how to perform the integration of the rational functions, and what do we mean by integration by parts. We will be explicitly solving numericals, and again it is advised that you go through the self learning material and attempt the problems through pen and paper mode, and also what these problems which are solved in this session. Both things will go hand in hand, and this will let you understand the topic in a better manner. So, there is a you might be thinking that okay, if integration is opposite of differentiation, then why should we study integration when we had already performed differentiation? So, there are countless real world applications in integration, and one of the common application is finding the area under the curves, which is at your level of understanding. Although integration and differentiation are required at very high levels also in the field of computer science, but for your level of understanding, calculating the area of the area under the curves, calculating volume of the solids, understanding and analyzing the motion and displacement of the bodies. Apart from this, what is the rate of growth and the decay, that is growth and decay related problems, heavily utilizes the concept of the integration. So, integration is actually another part of the calculus, which is actually opposite of process of the differentiation, wherein we need to establish the continuity. So, differentiation actually segregates the curves, but if those curves are supposed to be reunite, then how it is to be done. So that means integral calculus is a branch of mathematics that deals with the accumulation of the quantities, and accumulation means we are supposed to merge the quantities which are differentiated earlier. So both goes hand in hand. You will understand the process when we are going to solve the numericals explicitly in the sessions delivered. So there are two type of integrations. There are definite integrals, there are indefinite integrals. The definite integrals are actually integrals which are having some limits, and they are actually related to the calculation of the area under the curves. Apart from this, we are having indefinite integrals wherein there is no upper limit or the lower limit. So this represents the indefinite integral, and this represents the definite integral, wherein we are having the bounds a and b, and this type of integrals are frequently used for the calculation of the area under the curves of the function f x. So what do I mean by that? That say if there is a function, if say there is a coordinate plane x and y is equal to f x is a function which plots a curve, say this is the curve which is plotted, then what is the area under the curve? How to find that how much area is under the curve? Then in order to find this area under the curve, we need to perform a definite integral. Say we want to find the area under the curve between the region A and B. Then in order to find this, we need to perform an integration, definite integral of the function f x dx in the range a to b. So this is about the definite integral, and there are n number of applications of the definite integrals, and we will be discussing that how to use the definite integral to find the area under the curves between the and area also between the two curves. And it has got n number of applications, be it in the area of the cryptography or natural language processing or artificial intelligence or computational biology. So when we are going to deliver the content, I hope you will be enjoying the sessions, but I again recommend you to go through the self-learning materials along with the sessions delivered for the respective blocks. Likewise, block 1, block 2, block 3 and block 4. Block 1 and 2 we had already discussed about algebra. Block 3 we are going to discuss about calculus. So this is all about for this session. This session was introductory. I hope you got an idea that what we are going to cover in our upcoming sessions. Thank you.